Okay, YouTube, in this video I'm going to briefly cover how you graph what we call a piecewise function. Basically, a piecewise function is a function that is a function but is defined with, say, different rules over specified parts of the domain. So you can see that basically what I'm saying is our y values are going to follow this rule right here, but only for domain values that are less than or equal to 1 in this case. And for all values that are, say, just greater than 1, we're going to use this output rule instead. So what I would do is I would suggest that if you're going to graph this, I'm going to list these rules separately here. For 2x plus 3, we'll make a table of values is a good way to do this. And for negative x plus 4, we'll make another table of values. Essentially, what we'll do is graph them separately. And what I'm going to indicate here is your table, when you set it up, I don't know, a good battery of values, we say 2x plus 3 only exists for x values less than or equal to 1. So perhaps I say I'll put in 1 and I'll put in some x values that happen to be less than or equal to 1, like these right here. And for these over here, in terms of its x and y outputs, I should be writing f of x here, we're going to say it's only true for x values that are greater than 1. Now notice I said greater than 1, so I shouldn't include 1 on this graph, but I am going to include 1 in some x values that happen to be greater than 1. The one note I want to indicate, though, is this. On this right here, we are using this rule for all x values less than or equal to 1. So when we make this graph, we're going to put a solid dot on the graph at this point, whereas over here, since it kind of starts at 1 but it doesn't include 1, we're just going to put an open dot right here. So let's go ahead and plug in some independent variable values into our output here and see what we get for some outputs. If I plugged in 1 here, I get 2 times 1 plus 3 is 5. If I plug in 0, I get 2 times 0 plus 3. Well, that's going to be 3. And if I plug in negative 1, I get negative 2 plus 3 is 1. And if I plug in negative 2, I get 2 times negative 2 is negative 4 plus 3 is negative 1. So over here in this table, let's go ahead and fill out some values. We have negative input plus 4. So if I plug in 1, I would get negative positive 1 plus 4, which is 3. If I plug in 2, I'm going to get negative 2 plus 4 is 2. If I plug in 3, I'm going to get, okay, well, negative 3 plus 4 is 1. And I notice that these keep going down by 1. So to graph this, I notice these are both linear functions here. They're both first degree things. So I'm going to get a couple of lines, but essentially what it looks like is this. We have 1 comma 5 on our first graph. So 1, 2, 3, 4, 5. And we said we were going to put a solid dot there because it looks like this line if x is also equal to 1 there. We have 0, 3 on our graph, so we'll go 0, 3. And we have negative 1, comma 1, and negative 2, comma negative 1. So as far as what this graph looks like, we said it looks like the line 2x plus 3 for all x values less than or equal to 1. So this is the left side of our piecewise function. The right side of our piecewise function that starts at 1, 3. Now I'm going to go up over to 1 and up 3, but what I'm going to do is I'm going to put an open dot, okay? Because we're saying that it kind of approaches this y value right here, but it never quite gets there. So continuing to graph this, we have 2, 2. Well, over 2 up 2 is going to be here. Over 3 up 1 is going to be here, and over 4 up 0 is going to be here. And the right side of our graph is going to look like this. So often we will have functions that follow different rules. The best thing you could do for yourself, in my opinion, is just to make a different table for each of the rules and plug in the domain values that happen to be specified on the right side here. Cheers.